What you need to know about 3D rendering. If you are into 3D, you often hear the term 3D rendering. And if you are new to 3D, you may be wondering what 3D rendering means. You may get different meaning for it, but they all boils down to the process of creating an image based on three-dimensional data stored within a computer. It is a creative process similar to photography or cinematography where lighting, staging scenes, and images exist. The term rendering refers to the mathematical calculations made by the 3D software's rendering engine that translate the scene to its finalized 2D image.
3D rendering types. There are two major types of rendering where speed at which images are computed and finalized differentiate them from one another.
Real-time 3D rendering. This type of rendering is mostly used in gaming and interactive graphics, where images must be computed from 3D information at an incredibly rapid pace. Characteristics of real-time 3D rendering. Interactivity. Because it is impossible to predict exactly how a player will interact with the game environment, images must be rendered in real time as the action unfolds. Speed matters. In order for motion to appear fluid, a minimum of 18 to 20 frames per second must be rendered to the screen. Anything less than this in action will appear choppy. The methods. Real-time rendering is drastically improved by dedicated graphics hardware, GPUs, and by pre-compiling as much information as possible. A great deal of a game environment's lighting information is pre-computed and baked directly into the environment's texture files to improve render speed. Offline or pre-rendering. This type of rendering is used in situations where speed is less of an issue, with calculations typically performed using multi-core CPUs rather than dedicated graphics hardware. Characteristics of an offline 3D rendering. Predictability. Offline rendering is seen most frequently in animation and effects work where visual complexity and photorealism are held to a much higher standard. Since there is no unpredictability as to what will appear in each frame, large studios have been known to dedicate up to 90 hours render time to individual frames. Photorealism. Because offline rendering occurs within an open-ended time frame, higher levels of photorealism can be achieved than with real-time rendering. Characters, environments, and their associated textures and lights are typically allowed higher polygon counts, and 4K, or higher, resolution texture files.
3D rendering software. Since rendering relies on incredibly sophisticated calculations, today's 3D software provides easy-to-understand parameters that make it possible for artists to never need to deal with the underlying mathematics. A render engine is included with every major 3D software suite, and most of them include material and lighting packages that make it possible to achieve stunning levels of photorealism. 2. Most common render engines. Mental Ray. Packaged with Autodesk Maya. Mental Ray is incredibly versatile, relatively fast, and probably the most competent renderer for character images that need subsurface scattering. Mental Ray uses a combination of ray tracing and global illumination, radiosity. V-Ray. V-Ray is mostly used in conjunction with 3ds Max. Together the pair is absolutely unrivaled for architectural visualization and environment rendering. Chief advantages of V-Ray over its competitor are its lighting tools and extensive materials library for ArchViz.
Visit GarageFarm.net today and render your 3D projects with ease. Get $50 trial credits to test Render Farm service, with all features enabled without any commitment.